Welcome to my presentation for GIS 512. My name is Paul Schrum, and this presentation is my course project, Out of the Shadows. So this project came from a conversation with Dr. Krishna Singh, a postdoc here at the Center for Geospatial Analytics, and also partly a little bit from a conversation with Blake Baines about how can we get shadows out of raster images, or how can we somehow mitigate them. There's two problems we want to talk about. In a lot of overhead raster imagery, shadows become classified by some automated classification systems as water. So how can we distinguish water from shadows when it's so easy to do for a human? And then once that is working, we would like to be able to take shadows and increase the brightness of them in an appropriate way so that they when later classified by downstream processes, they are considered to be the correct land cover type. So to do this, we're going to look at some statistics. The first step of my process was to find certain areas and classify them visually, just by naming them, and then some of those are shadowed areas, and then some of those are sunlit areas. Here is an example of shadowed fallow ground next to sunlit fallow ground. And for each of these rasters, we do a mask, and so we have subset rasters, which are only the masked area. And then we have the statistics for each of those. And we look at the statistics for each band. So if I have 16 areas, 16 rasters, and each raster has 4 bands, that's a total of 64 bands. Here are the statistics for one band. You can see here that the total of all 4 bands has an average of 60.9, but each of the individual bands have a mean that is different, which would correlate to the color of the band, the color of the raster. So we computed statistics for the whole raster, all 4 bands, and we computed statistics per band. And that's just a quick example of some of the 16 rasters that we computed data for. So the first question, how can we distinguish shadows from water? When we look at the average of water versus the average of vegetation, shadows over vegetation, the averages are close together and they would be hard to distinguish using statistical methods. But when we look at just the near infrared band, band 4, we find that for water the average is 21.6 and for shadow it's 60.9 in this particular image. And so these are distinct statistically, so we can use band 4 as a way to separate true shadows from water sections. And so then, once we know that, how do we change the pixel values to match the sunlit sections? So what we do is we are going to come up with an algorithm. We haven't done this for the project, but we are proposing this in the project. Come up with an algorithm that takes the pixel values, pixel by pixel, of each shadowed area, computes the mean and standard deviation in the P80 range, and increases those values to be closer to what they are like in the sunlit areas. So then, what do I mean by the P80 range? Well, P80 range is just this thing that I invented that shows if this bar is P10 and this bar is P90, I want to get the minimum and the maximum from P10 to P90, and I call that the P80 range. So then we want to increase the pixel values so that the statistics are approximately the same. Then we will merge the shadow raster back into the main raster, the shadow rasters back into the main raster, and run the classification of any different kind to see if we can get those corrected shadow areas to classify correctly in the automated classification routines. And that is the end of my the video for this project.